And we're gonna keep rocking with Dan. Where you at, bro? There
Hey,
he
how's it
is.
going? I'm calling from London. So a
Oh,
little bit
so
later in
it's
the
a
day.
little late. It's a little late. Then I'm gonna let you get moving real quick. I see you shared your
Yep,
screen. I will get rid of that and let you start rocking and rolling.
sounds good. Well, yeah, really awesome to be here. Thanks a lot for the very kind introduction. Yeah, so my name's Daniel Lenton. I'm the CEO and founder at Unify. We're kind of playing around with the slogans a bit, but yeah, for this talk, we're going with all AI in one API, and I'll be talking about how we're trying to effectively unify the LLM endpoint landscape. Yeah, in the product we've released recently. So let me very quickly. There we go. It says working. So the first thing to note is that basically, what we've seen is that the number of endpoints has exploded a lot recently. So there's a lot of companies that were conventionally doing kind of pure infrastructure. There's obviously Anyscale and Ray, and there is Octo ML, now Octo AI, and many companies together. AI do a lot of compute as well. What we've seen recently is that there's a lot of different AI as a service endpoints coming onto the market. This can be existing models that are exposed as very efficient, very cost-effective endpoints to build kind of verticalized LLM applications. It can obviously be text-to-image models like Stable Diffusion, etc. But there's more and more of these coming onto the scene, not only with their own interesting, unique cost-performance profiles, but also with their own unique, specialities. There was recently text-to-SQL models that are competitive with, GPT-4. Of course, Google releasing Gemini and Gemma onto the scene as well. So there's a lot of interesting stuff coming out all the time that is both, adding to the performance profiles and also the actual quality of these different endpoints. And basically, when you deploy these, there's such a maze when you think about how you can deploy these. There's so many options because with the whole Gen AI boom, not only are there more endpoints, but there's lots more models. So there's Mixtral, there's Mamba, there's all these new things coming out, all these interesting technologies. There's a whole load of serverless GPU options and a whole load of kind of orchestration technology going on. Lots of really interesting stuff, removing cold start times and things like this. There's a load of compression techniques coming out all the time, a load of compilers. So there's XLA, TensorRT, OpenAI Triton, Mojo, kind of with its own MLIR dialect and so on. And of course, the hardware landscape as well. NVIDIA remains in a very strong position, but there's great hardware from Intel with the Gaudis. There's AMD entering the scene. There's Samba Nova Systems, Cerebras, etc., etc. So all of these areas of the stack are seeing a lot of innovation, a lot of stuff going on, and the combinatorial search space across all of these is very vast. And that just means that this endpoint landscape is even more diverse because there's so many options to really squeeze the performance out of these models that are deployed. And yeah, getting the best performance is very much a trade-off. So, one application, some applications you want to have low cost, others you want to have low latency or high accuracy or high throughput or low memory. And these things are all in direct competition. So, you can get high throughput by just having a ton of idle devices, but that's then going to cost you a lot of money. You can have very low latency by doing heavy compression, but then you're going to sacrifice accuracy, etc. So these things are all in direct competition, and every application has its kind of optimal combination of these things, which is non-trivial to arrive at when you're looking at these solutions that are out there. And the other observation is that the current benchmarks, well, saying they're flawed is maybe slightly strong, but that there's certainly issues to be resolved. So as many people will know, the actual quality benchmarks in LLMs are sensitive to small differences. There's some really interesting work showing if you kind of use capitalized ABC with the options or non-capitalized or 1, 2, 3, it can change the rankings of these models. There's issues potentially with models being trained on the benchmark data, so there's contamination issues. A lot of the benchmarks are very narrowly scoped, which also means that there's the risk that models can somewhat overfit to these benchmarks, even if they've not actually been contaminated. So these are just some of the issues that exist with the quality benchmarks. And the other issue with kind of runtime benchmarks is that these things are not static at all. So when you look at any of these endpoints, they are constantly changing through time because, of course, these are not static systems. They're dynamic. The performance you get out depends on the load balancing that's going on at that point in time, the amount of user traffic that's going on, of course, software and hardware updates behind the scenes of these black box endpoints, network speeds, geography, and so on. And these are incredibly dynamic systems. And I think we need to think about them as dynamic systems rather than kind of static leaderboards, particularly when it comes to runtime performance, which is not really an intrinsic property of the weight of the model. It is an intrinsic property of the dynamic system. So what I think is needed, and what we think is needed, is that having basically open source benchmarks which are target agnostic, so aren't specialized to any particular LLM, with an open governance approach where the data is kind of quite raw. So really focusing on the very bare bones metrics such as time to first token, inter-token latency, etc., in a very user centric way. So what is it that the end user would actually observe when they go and query these endpoints at any point in time? So this is what we think would be quite useful addition to the runtime benchmarking landscape. So another thing that's needed to be considered is you need to have a uniform tokenizer, because the tokenizer changes how many tokens any given sentence or word goes to. So when you do kind of tokens per second or cost per token, we need to be talking the same language. So you need a standardized tokenizer when you do any of these comparisons. You need diverse inputs, because obviously with things like speculative decoding, if you have very repetitive inputs and so on, then this can actually change performance. You need varied regimes, so in terms of concurrency and in terms of geography and so on, because these things change with all of these things. And also these metrics that everybody knows about: the time to first token, the inter-token latency, etc. So what we've tried to contribute, and hopefully is useful to people in the field, we've created ongoing basically dynamic runtime dashboards where you can go onto the hub and you can see all of these performance metrics as they evolve through time. And what this really shows is that actually these things are incredibly non-static. If you take a look at this performance evolution across time, and this is going from kind of February 3rd to February 17th, so this is kind of a kind of week or two, and you can see that sometimes one is the best, sometimes another one is the best, and these things are really very, very dynamic through time, basically, is the main observation we have, which means that really a time series perspective is the correct one to have when you think about the runtime performance of these benchmarks, basically. And what most people do, I guess you could think of it as a static router. The typical approach is to basically, work with one provider, work with one endpoint, and then stick with that. And then, things like latency and throughput vary across time, but that's okay. You're just sticking with one provider, and all of your requests go to that single provider. One arguable downside of this is that basically, these things change a lot. So sometimes the performance is very high, sometimes the performance is not so high. And it's great when it's high, but when it's not so high, you're left waiting a bit longer. So you have a suboptimal overall solution. So what we think would be useful in this space is actually even just thinking about something as simple as runtime performance, without even getting into quality-based routing or anything yet. Just dynamically routing to the highest performance endpoint at any point in time can give significant speed ups. When you're working with these models. So the idea is, if we can take the kind of top band and effectively do an argmax over the performance, then you can actually with having this dynamic routing and single sign-on, you can get performance which is better than any individual provider, and actually is kind of the argmax across all of the providers, which is very useful for end users that then just want to make sure at any point in time they're optimizing for their runtime performance, for example. So this is the insight we've had. So just to put this in a concrete format. So again, with two concrete examples here, each endpoint fluctuates on any given day. And we've got Llama 270B chat here and Mixtral here as well. Again, you see the performance varies quite a lot. And what effectively we're doing, visually, is taking this and just taking the argmax, and that actually improves the performance quite significantly. And with what we've seen so far on CodeLlama 34B, Instruct, Mixtral, and Llama 270B chat, we see quite significant improvements when you take the argmax versus the second best individual provider, in the order of up to 3 times better. Sometimes when you then 3 or 4 times better when you consider this unrolled over the space of a week or two, because again, sometimes there are like slight drops in performance. So this is relatively simple, but again, like quite big performance gains to be made by a relatively simple approach. And And again, like basically this can be based on any metric. So you might want to optimize for time to first token. You might want to optimize for inter-token latency, etc. So it really depends what you want to optimize for, but you can choose, whatever works best, basically. So I will very quickly, very quick demo, show you what this looks like in action. So let me quickly share my screen. So basically, what we have here. So let me quickly do this and quickly open up this as well. So you can imagine, So you can imagine that basically, let's say we want to optimize for, we want to optimize for throughput in one case, and we want to optimize for time to first token in the other case. So bringing this up here, basically, we can see that this is how you would do it. So basically, let me quickly do this, broadcast all. So what I have is this simple agent class. And this is something that's in our docs, but just a very simple agent class that kind of connects to this centralized router. We can then do agent equals agent, and we specify what the provider is. So in this case, we're going to do Llama 2 70B chat. So we put that in there, and then we do @ and what we can do is actually select a mode, which is not one provider. So one thing we can do is we can say at any scale, or we can say at Together AI or at FireXI, etc. But what we can also do now is basically select a mode. So we can then do kind of at, let's do one that's lowest time to first token. So let's do that one for this. Oh, sorry, hang on. I need to undo this. So let's do broadcasting off. So let's do that again. So this is lowest time to first token, and then this one is actually going to be, let's say, highest tokens per second, like so. Let's get that there. So again, we're not specifying one provider. We're actually specifying a mode, which will then look at the latest results and act accordingly. So right now, we are, let me quickly go back to the hub. So right now, I'm calling from London. So what we would do is look at Llama 2 70B chat. The closest is Belgium, so that's probably a reasonable approximation. So then, let's see what we expect to be the selected provider. In terms of output tokens per second, right now, the highest performing is Together AI. So I would expect that this one is likely to be Together AI. The one that's doing best for time to first token right now is Octo AI. So that would likely be the one that's chosen here. So let's now put this in action and see. So I'll quickly do broadcast all again. Let's do agent.run. There's two options here. You can see it in the docs. One of them is to print the cost that's spent, and one of them is to print the provider that's being used under the hood. So let's run both the agents. And then, I don't know, let's say, so there was one I did that's just like, because it shows the performance quite well. So, count from 1 to 100 using words, not numbers, using a new line per number. So what we would expect to see, and I mean, this is a live demo, so let's see. What we'd expect to see is that this one starts quicker. So the left starts quicker because we're trying to do time to first token, but the right one, goes through the numbers more quickly, and then we'll get shown at the end because we've set the logging to true. We'll get shown what the provider is that's being used under the hood. And I hope this works. If it doesn't, then I'll have to record it. But so although they did start similarly actually in this case, but you can see the one on the right goes through way faster. And the time to first token is something that's quite noisy actually. So yeah, we were able to get Together AI was the one that was selected on the right because this is the one that has substantially the faster inter-token latency. And then the one on the left was Octo AI because again, this is the one that was selected to have the best time to first token. And the benefit here is, and you can do the same with cost. So like, for example, let's say that, the costs change every few weeks or so on, and you don't want to keep up with this. So you can just say, well, I just want to do, if you're doing a very input cost dominated task, such as, chat interfaces where you keep sending the entire chat history as an input, you can just set this mode and just know that at any point in time, you're always going to have the cheapest. If you have a very output dominated task, such as, I don't know, content generation, or you want it to make loads of marketing material for you, then you can select the lowest output cost. And again, you can rest assured you will always have the cheapest among the providers. So even just very simple rules like this is quite a useful abstraction layer to make sure that you're getting the very best out of these all these great providers with all these great different endpoints. So that was the end of the very quick demo. I know we're kind of quite tight on time, so I'll fly through the last few slides.
Yeah.
So yeah, so basically and I'll fly through these. So future directions we're looking now at doing, as well as this quality-based routing as well. So we've shown here simple runtime-based routing based on simple handwritten rules, but actually doing a learned system that can route to the best model for any given prompt. For example, you can imagine, what is the capital of Egypt? This doesn't need to be answered by GPT-4. Llama 7B can answer this totally fine. So we can save a lot of time and money by routing it to that accordingly. Similarly, if it's a SQL text, maybe we send it to one of the fine-tuned SQL models that are actually better than GPT-4, etc. So quality-based per prompt routing is another area that we're looking into. And then you can train this, for example, with human evaluation, much like the way that Chatbot Arena is trained. You can also do this with LLM oracles to help learn the routing function as well, something that we're working on at the moment. And we also see multimodal routing has been an interesting potential future direction where, similarly to what you get with GPT-5 and so on, where it can, do things with images and audio and so on. Actually, if we see the endpoint landscape expanding and lots of very good niche models appear across modalities, then I think routing across modalities as well to get the very best for every request is a really interesting area for future work as well. And again, basically, it's all based on the standard OpenAI standard. So basically, you just send your HTTP request with the exact same content to a different, to our URL with your API key, and then we can kind of route it to the most appropriate one behind the scenes. And again, you can find all this in our model hub, basically. But I'll try not to go over it by too long. So that was just a very quick demo, very quick overview. But yeah, thank you very much for listening, and very happy to answer any questions. Thank you very much.
Dude, very cool. Thank you for showing us that. I have one thing that I want to ask you right away, because I've played around with another playground type solution, and I've noticed that depending on the endpoint provider, the model is, or the output is higher or lower quality. So what's weird to me is that I'll have the same model selected across a few different endpoint providers.
Yeah.
And the output will be drastically different.
Yeah. So this is one thing that we are working on as well. So as you say, the prompt-based routing between providers will be strongest when the model is different entirely. But for things like quantization, there are some endpoint providers that are focusing on improving the speed through things like compression, which of course does change the quality. Now it's very hard, obviously, with these being random, to know whether that's to attribute down to the temperature and the randomness, or down to the actual the difference in the model. But one thing that is very much needed in our benchmarking and everything is quality-based benchmarking. So we intend to not only plot the performance across time, but actually the quality across time, because of course that's quite hard because there's a lot of noise. But that's something that I think is doable, because then if one provider decides to compress their model, that should also emerge as a time series data as well. So it's very much on the radar, and we're thinking about, but it's very hard. Runtime is relatively objective, so there's not too much disputing. Quality is as a whole other game altogether. So we're thinking very carefully about how we do that.
That's the only thing I would caution people against. So I love Together. I love their product and what they're doing. And Jamie, one of the founders of it, I've talked with a few times. But the Mistral model in Together, it's so fast, and it is really for some reason, I can't get it to give me a good answer. And then you go to the Mistral API itself, and I'm pretty sure they're doing some special sauce behind the scenes to make their model much better. And so if you're just looking
I find this very interesting. Yeah.
Yeah. I swear, man, they're making their stuff like if you get it from them, it's really good. And they say it's just like the normal model.
Well, hopefully this is the kind of thing that would become emergent through the kind of time, through benchmarking. But again, it's so hard to do benchmarking reliably because you need to do it with a lot of data and
Mhm.
yeah, it's something we're thinking carefully about. But I would love it if we could have that kind of presented in this sense as well. And also, I very much talking with the founders of these companies and all doing really good. There's more broadly speaking, very much on board with open benchmarks. Obviously, there's LLM-Per from Anyscale. That's a great initiative. There's initiatives from Fireworks as well have one, and Martian Router have one. So I think there is a good like joint initiative to try to get objectivity here, which is great to see. So yeah.
Yeah, it is super cool. It's super cool to see. I really appreciate what you've built and what you're doing. I will let you go, man. I don't know if I see some people are just mentioning this was awesome, great live demo, and
No, thank you.
others are saying like, yeah, for my company, accuracy of output is more important than
Yeah,
like money. Or
yeah.
and I think,
That's good to know. We
yeah.
want user feedback. So if there's some feedback in the comments, that's perfect. We'll make sure to get it added.
That's it. There you go. So if anybody wants to go and check it out and get in touch with Dan, hit him up. That is perfect. So Dan, we're gonna keep on rocking.
That was good. Amazing. Thanks so much.
Yeah, get some sleep, man. I know it's late where you're at.
Will do.
I appreciate you doing this all late. That's very kind of you.
Thank you very much.